Okay, so now continuing to look through this paper by Nelder and Wedderburn on generalized linear models. We are currently in section 2 on the maximum likelihood equations, and right now we are looking at equation 8. Okay, just as a reminder, this is part of a playlist. The complete playlist will be included in the description of this video. So equation 8, it starts right here after the word and it runs through all the way to this period right here. It's a big equation. Okay, or there's a lot to talk about here, I guess, is really what I mean. So let's go ahead and I'm going to break this up into 3 parts. Right now, I just want to talk about this first line right here. Okay, so I wrote it here. The second derivative of the log likelihood with respect to beta I and beta j is the second derivative of the log likelihood. I think I'm missing a 2 there. Xi times xj. Okay. So to show this, let's start with just the first derivative of the log likelihood with respect to beta I. Using chain rule, this is the same thing as the first derivative of the log likelihood with respect to y times the first derivative of y with respect to beta I. You can kind of see how they cancel. This is chain rule. The reason this is really nice is because if we remember what is y is the sum from k equals 1 to m of beta k x k. Now you might see it in the paper, it's written as I, right? I equals 1 to m, but I don't want to get confused with this I here, right? This is indexing from 1 to m. In other words, this is the same thing as saying beta 1, x1, beta 2, x2, beta m, xm. And so when I take the derivative of y with respect to one of those betas, doesn't matter which one, beta I, anything that's not beta I will cancel because it'll basically be a constant. And then when I run into the term that is beta I, the beta will drop and I'll be left with the corresponding xi. Okay, so this is really nice. This result goes in right here. Okay, so let's go ahead and plug that in. All right, so this is the first derivative. So now I just need to do the second derivative. Okay, because this is ultimately what I want to show. Beta j, second derivative. Now remember, a second derivative is just the derivative of the first. Okay? And the first derivative, I just showed what that is. Okay. Okay. So now, all I did is I plugged this in, right there. So now I can rewrite this, write this a little differently. Oops. I'm going to rearrange the order of my taking the derivative. Okay, which I can do under certain conditions. So this is good. The reason why I like that, the way I've just written it, is now I can basically do this chain rule again. Okay. So I'm taking the derivative. Let's see, this would be dy, d beta j times xi. Okay. Okay, now dy d beta j, similarly dy d beta I is xi, so dy d beta j will be xj. xi. Okay, so now I'm almost there. Notice that this is a derivative of a derivative, which is basically what a second derivative is. So let me write that as a second derivative. And then I think they had xi, xj. So they rearranged the order of the multiplication, same thing. So there we go. We've shown that first part of equation 8. Okay, and then in the next video, we'll focus on this piece right here. Okay, and what is that?